Let's get started with 9.2 and 9.3. 9.2 is solving systems by substitution, and 9.3 is solving systems by the elimination method. Remember, with systems of equations, we're going to have one solution, no solutions, or infinitely many solutions. And then we were talking about in a previous video that you're going to learn these three different methods, or four different methods of solving systems of linear equations. Most of you will probably adapt to the fourth method using your TI-84 once you've learned these other three methods, but you are responsible for being able to do all four of these methods. Okay? So this is what your note packet looks like from 9.2 and 9.3, and I highly recommend you read what I've written here. It talks about how some cases are good for substitution and some are good for addition. In my mind, not that many are that great for the graphing method, but sometimes you can see right away if it's in slope-intercept form that the slopes match, and then you would know it's one of the special cases. So taking a look at this one, it says this one is an awesome one for substitution. Okay, and the reason this is a good one or awesome one for substitution is that if we look here, we have a variable isolated. It says y is equal to 3x minus 6. So what we can do with the substitution method is we can take this y value, because that's what y is equal to, and we can put it into the other linear equation. And so what I'll have then is I'll have 6 from the 6 up front here, and then I'm putting in, not putting in for the x value, so I'm going to write x and plus, and then I'm substituting in 3x minus 6. It's most often a nice idea to put this inside of a parenthesis. It's not that helpful in this problem, but if there was a number up front here, we would have done the distributive property. And then I have equals 30. Now that I have this in one variable, I can just use my algebra skills to solve this. I'm putting my x's together. I have 9x minus 6 equals 30. Add 6 to both sides. I get 9x equals 36. And divide by 9, and I get x equals 4. Now, when I first started doing these, I was really excited at this point. I'm like, oh, x equals 4, that's great, and I finished my answer right there. But your answer is not complete, because remember, when we solve a system of linear equations, it's an intersection of a point. So we have an x value and a y value, and so far we've only found the x value. Okay, what we have to do is go back into one of the original linear equations here and solve for y. And so usually one is maybe a little easier than the other, but if I notice that I put my 4 right into this equation, it's going to be pretty easy to do. Up here I'd have to do a little more algebraic manipulation, but here I have y is equal to 3 times 4 minus 6, y is equal to 12 minus 6, and y is equal to 6. Okay, and so that's the point of intersection. All right. I want to show you real quick in Desmos what this looks like. I've typed in both of the linear equations as they were given to us here. I didn't even have to change them to slope-intercept form. And what I found was that the intersection of those two is at 4, 6. So using this, using Desmos can be a nice little thing to check your answer also. Okay, so we'll do one more here. Looking at this one, this number 2 from your note packet. It says this one's not the best for substitution, but it'll work. What we'd have to do on this one is in either the first linear equation or the second linear equation, we have to isolate one of the variables. We need to get one of the variables to say x equals, or one of the linear equations to say x equals or y equals. And if I look at the second one here, what I can do is I can divide by 5, and I get y equals 2x minus 3. So I kind of think of that as, that's my new line 2, okay? I think of this one as line 2 and line 1. Alright, so it's still this, if I graphed it, it'd be the same as the original one, okay? It's just in a different form. So now that I know that y is equal to this, what I'll do is take this value, this 2x minus 3, and I'll substitute it in, and I'll draw a little arrow here. I'm going to substitute it into the original line 1. So I have negative 5x plus 2x minus 3, and then equals negative 12. Okay, and this isn't too bad to solve. I can put my x values together. I get negative 3x minus 3 equals negative 12. I can use the moving technique or the add 3 technique here. I'll just move that over, so I'll add 3. So I have negative 3x equals negative 9. Just checking my notes here. Seems like I have an error on the note packet that I'll have to fix for you, but I got x equals 3. Okay. Once I find that x equals 3, don't stop there, because I only have this part of the answer, and I'm going to take that and I'm going to go back into one of the original equations. So maybe I'll put x equals 3 into this first one here. So I have negative 5 times 3 plus y equals negative 12. This is going to be negative 15 plus y equals negative 12. Add 15, and I get y equals 3. Okay. So, all right. I could double check that in Desmos. I probably will after this video, just because I noticed an error on my note packet. But that's a good start to solving by substitution. I'm going to make another little video about some stranger cases in solving by substitution, meaning the ones that we get no solutions, or the dependent, where the two lines are on top of each other. All right, thanks.